folks, welcome back. This is the last installment of our first unit. Today we're going to talk a little bit about identifying human remains versus non-human skeletal remains in the field. This will cover a few different things, including a little bit more in depth of what we hit on the first day, or I think it was the second lecture, where we talked a little bit about how we find remains in the field. So we're going to go into a little bit more detail on that. We're also going to talk a little bit about how we differentiate between human and non-human. Honestly, that is the part that I get the most consternation about from students who are going into forensics. That is, oh my God, do I have to know every single non-human thing out there to be able to identify it? The answer is no. And we'll get into more detail about that later on. Okay. So this is what a typical site looks like. After the police have been through, the first responders, whomever found the initial idea, then what we often do is get a police line, that is a group of people, or we do the spiral search, and we start planting flags into things. Now, in some jurisdictions, they'll have color coordination of flags, but most of the time it's just random flags. So the colors have nothing to do with anything. Here you'll see yellow flags and pink flags and possibly some white ones. That has nothing to do with what was there. In fact, usually when we have the initial policing, it's done by a lot of people who are not well trained necessarily. So they just mark anything that looks like it might be bone, might be something of interest. So it depends on what we're looking for, and sometimes we'll go to something of interest. Usually it includes things like jewelry, personal items, things like that. And of course, a weapon. In the vast majority of forensics cases, I would say nationwide, somewhere around 25 to 30% of presented cases are non-human in origin, meaning the bones that they bring in to a forensic anthropologist are usually not human bone. This number goes up dramatically in cities, though. I've mentioned that before. In the city, we usually get the vast majority of what we get is non-human bone that city folk just don't recognize as animal bone. In the country, people recognize non-human bone much better, mostly because they're working with it, or they're hunting, or there's something like that. So they're more in tune with what's going on around them in the woods and forested areas. Whereas here in cities, we don't get that as much. Therefore, if somebody who's a hunter on the weekend brings home and dumps a bunch of skeletal material from, I don't know, a pig roast, or a deer that they shot, or even a turkey or a bird or whatever. Sometimes, especially if they're human in size, roughly, like a pig or a deer, then we get called in, and usually it's not. Access to and comprehensive comparative collection. A comprehensive comparative collection means that we have a lot of non-human stuff that we can work with and compare to. Almost every good-sized coroner or medical examiner's office will have a pretty good supply of non-human stuff that tends to be in the area for a comparison. It's a good idea to familiarize yourself with the more typical ones, and just one or two things that stand out as being not right. But as I alluded to on the last slide, really, if it's human, we should know human bone better than anybody. So if it's human, you should recognize it. If it doesn't look right, it's probably not human, and there you go with that. There are some exceptions, and we'll talk about some of that. And we'll talk about the things to look for later on. Okay, as I mentioned before, there are 10 fundamental questions we ask. The first one is it even bone? And make sure it's not wood, shell, or plastic, or some sort of rock, or mineral, or something else. Okay. Here are a couple of typical pictures of what we would find when we do find bone in the field. You can see the image to your right with the trowel stuck in the ground is pretty obvious that there are some bones sticking out there. You can see them over on the left-hand side of the picture. Um, in this case, the photographer stuck the trowel in the ground to show you kind of size comparison. Um, these are typical bones that you may find out in the field in a tough terrain, and sometimes they stand out quite clearly. Here you have a piece of dirt and some pretty obvious large bones. Conversely, on the side on your left, the image with the little S marker on there um, is a really, really tough find. This is one of the ones I was so proud of when I found this thing because it stood out to me, but it's hard. It's very hard to see. Um, if you can't see it, it is in a swampy area, so we've got all kinds of overgrowth, and it's really hard. Also, this skeleton had been scattered quite a bit by the scavengers, but I'll point it out for you. Right here, there is a human rib bone, right there, which looks a lot like all the sticks and detritus that's laying around here. And there it was. Now, this, you can see we're actually on a game trail. This is an area that's used by coyotes and deers quite often. This is in a Louisiana swamp, which shows you it's really hard to spot these things oftentimes. So it takes a trained eye. When we're just walking along, we look down, we're like, oh, that's human. Okay, is it cranial or postcranial? Now this is in a little extra one outside of our 10 fundamental questions. Is it cranial or postcranial? Most cranial bones are thin, flat, and sort of look like, I don't know, like a rounded, flattened piece. It may look like tortoise shell, which is often confused for it, or like a ostrich egg, which is also sometimes confused for it. Not by us, but by bystanders and first responders. Conversely, postcranial bones typically look long and thin. They're not all long and thin. You know, there's other things like the scapula and stuff like that. But here you can see some pretty obvious bones. The ones on the really more of the right-hand side of the picture, those are all cranial bones. You can see that big, wide, flat, kind of rounded shape. Furthermore, it's underscored by, you can see some teeth toward the top there. Then midway across, I believe that's a scapula. It's hard to tell. It's a little out of focus. But then to the left-hand side of the picture, you can now see those are typically postcranial bones. We're talking arm and leg bones there. Are these the bones of an adult or a juvenile? We're looking at overall size. Are they fused or unfused in the epiphyseal areas? Now, pay attention here. We're going to, again, pay attention first to the lower right-hand image. You guys see this fusion joint here? We talked about it the first time, in the first slide, in the first episode, I guess I'll say. We have the epiphysis. This is the articular surface, the part that makes up the joint. And then we've got the shaft, which is called the diaphysis. This has a specific type of fracture called a butterfly fracture. We'll talk more about those later on. What we have here is an epiphyseal plate, this area of non-fusion. This tells us this is a juvenile. It's a child's bone. And up here you can see it even better in the knees of this kid. We have a child who's been burned, but here you have the diaphysis, the shaft. Here you have these separate bone pieces on the ends. These are the unfused diaphysis. Now, throughout this child's body, you'll find those things. You'll find them in the humerus, radius, and the ulna. You'll find them in all sorts of parts around the body, but really toward the joint surfaces. All right? Human versus non-human. Here's a bunch of scatters of bone. There are things to look for. First of all, in this first one up here in the upper corner, you can see it's got kind of a peculiar looking skull, obviously not human. Similarly, its pelvis, obviously not human. It's got these funny little plates of bone everywhere. Here's some more. Those plates all fused together. Interesting find. This was again in Louisiana. This is just beside the street. Long story that. But what we're looking at here are bones of various things. Here you see a vertebral bone, and you see this very, very round cross section of the body. This is the articular part of the body of the vertebra. If it's round like that, extremely round, this is often associated with fish. Can also be some of the larger quadrupedal mammals, like for example a deer. Can also have these very round cross sections of vertebra. And then down here we've got yet another shot of the scatter. Incidentally, these bones here are really telling of what this animal was. And I'll leave it up for you for a guess as to what you think this animal might be. It's small. That's what I'll leave it at. Most mammalian bones share similar morphological features between species. That is, every mammal, from bats all the way up to horses, are going to have a humerus bone. They're all going to have a radius and an ulna. They're going to have the same bones of the mouth, a mandible, for example, maxillae, the nasal bones. They're all there. Some may be fused a little differently than others, and there's certainly going to be different sizes and shapes. That's the important part to pay attention to. Primary difference is size. However, some animals, such as deer and pig, have bones that are very similar in size to an adult human. That's why they're quite often mistaken for an adult human. So those types of bone are better to get fairly well acquainted with, and why there's a difference. The nice thing about both deer and pig, in fact, most large mammals, we're the only one that walks around on 2 feet. All the rest are what we call quadrupeds, meaning they walk around on all fours. Yes, that includes chimpanzees, gorilla, orangutan. Okay? And bonobos if you're really going that way. Bear paws, raccoon paws. They can look like hands. Raccoons, hands of children usually. And we talked about that on the first one. I'll show you some examples. Snake vertebra and horsetail can often look like finger bones of humans. Here are those two comparative samples. Which one's human? Which one is a bear? If you guessed the one on the left is human and the one on the right is bear, congratulations, you're correct. Here we've got a child's hand. You can see the size of the child's hand. You can also see that those bones have not fused. Remember I said in that infant that we saw, the baby that had been burned? We saw all around there, actually it was a child, all around there we see all these unfused areas of bone. Do you guys see all these? They're all unfused. These are the epiphyseal plates, the unfused plates. But you can see that this child's hand can look an awful lot like a raccoon paw. Now, unfortunately, especially the forepaw, the front paw of a raccoon, I do not have any bones of a raccoon paw to show you, but they look a hell of a lot like those human hand bones. All right? All I have is this muddy footprint to show you the size is similar. Now, granted, a raccoon paw is generally much smaller than most child's hands overall, but the bones you see are not fully formed in the child's hand. Therefore, these bones are very short in comparison to the overall size of the hand. Therefore, if you were to squish these down, they would actually fit. But what's different? These plates. So if this was all fused, then you know it's probably from a smaller creature not a growing child. All right? Human versus non-human, as I mentioned, pretty obvious in size and shape for the most part. Here we have an elk or an antelope here. Here we have a dog. Here we have a human. Obviously, the skulls are the most obvious. But the ribs in everything that's not human tend to be much sort of flatter, straighter. Human ribs are very curved. The pelvis is very different. The proportion of the limb bones are very different. And overall, the shapes are the biggest thing to make note of. They're different. What if you come across bones like these? These can be very difficult to see. But here we have some foot bones. And here's a very weird one. This curved bone. This is a humerus, meaning it's the upper arm bone of a human. As I mentioned, all animals have humeri if they're mammals, but ours looks very peculiar. This one's very bent. That's an interesting aspect of it. This is from an atypical human. This is from somebody who is suffering. It's an adult who has achondroplasia, which achondroplasia is a dwarfing abnormality in which their bones don't grow to their full length, especially their limb bones. So that's what that is. Okay? Humans are bipeds. All other mammals are quadrupeds. So our pelvis is very broad and shallow, kind of bowl-shaped, whereas their pelvises are long and narrow. The femur is the longest bone in the human body with a single linea aspera. The femur is often shortened in quadrupeds, which is kind of counterintuitive, but it's because their lower leg is usually elongated. The body size with a double or plateau linea aspera that runs down the back side of the bone. Don't worry about most of these things. These are much more advanced than where you're expected to be. I'll never test you on these particulars, okay? The tibia and fibula, this is the lower leg bones in a human, are separate bones. The tibia is triangular in cross-section with a small tibial tuberosity. That is the bit that allows for the connection of the patellar tendon, which you've probably already guessed is where your kneecap is installed. The tibia and fibula on a quadruped are often fused, specifically in things like goats. They tend to have what's called a cannon bone, which is not a separated tibia and fibula. Legs of larger mammals that are often hoofed have modified toes and fingers for speed and agility. Therefore, they're elongated, and their humeri and femora are much shorter. We have a long, narrow, very, very peculiar looking foot, and most other animals do not have feet that look like ours. The closest, as I mentioned, were the bear and the raccoon. But boy, if you look at size and if they're intact, you'll see claws on the ends of all of those, not on a human. All right? Here's some pictures to clarify some of that stuff. On the left are the bipedal humans. On the right are the quadrupeds. The left-hand side, we have a typical human pelvis, where you can see that sort of shortened bowl shape. It's hard to see in this image. It's much easier if you can pick them up and see them. On the right-hand side, we have a chimpanzee pelvis. You can see it's much flatter and elongated compared to the human. Conversely, and oddly, I have these on their side because they didn't quite fit. I should really redo this slide. But we have a human leg on its side on the left, and on the right, we have a horse. Now, let me show you some of the differences. First of all, remember, the horse is running around on a single toe. That's a toe bone. These are its metatarsals. These are the bones that are here in the human foot. Toe bone is here. Here's the metatarsals. They're all squished up in here. And you can see most of them are fused together in the horse. This is our calcaneus bone. This is the horse's heel bone or calcaneus bone. Here is the tibia with a fibula, which is virtually fused to it and very, very tiny. Here is ours, which are completely separate. Tibia is the larger, fibula is the thinner one. Then we have our kneecap. Here's the horse's kneecap. Then we have our femur. Here's the horse's shortened femur bone. And you can see now it gloms onto where the horse's hips are. This is the horse's pelvis starting here. So you can see this femur is much more shortened compared to ours. And the tibia and fibula in the human are separated, whereas in the horse and many other quadrupedal mammals, they are fused. All right? Vertebra. I mentioned this before, but humans have a large, flat vertebral body. That's this kind of biscuit-shaped part down here. There are a lot of other things that we can look at. We're not going to go into too much detail here. The spinous process is the other thing that I want to point out. That's this little thing. That's where the word spine comes from. It's actually an attachment point for muscles and tendons that run up the middle of your back. Ours is very shortened. Quadrupeds, this is their spinous process. It's very elongated. You'll see this elongated spinous process on a lot of fish as well. It's because they're supporting a lot of muscle with that bony extension. We are not. Okay? The forelimbs. Humans' forelimbs are designed for rotation, for throwing, swinging, moving, swinging hand over hand. We can climb on monkey bars, things like that. Our clavicle, we have a collarbone, which is there. Again, you guys, this is way more detail than I ever expect you to get into in this class. This is just, I'm just giving you the information, but I won't test you on most of this stuff. I'm not going to get into this much detail. I would say things like, you can tell the difference between a human and a non-human because most non-humans are quadrupeds. That's what you would come up with. Does that make sense? Okay, so the humerus, the radius, and the ulna are not weight-bearing. That's our arm bones. So they're not very big. They're not very robust. That's a word that you'll see typically in anthropology. It means very heavy or thick. Think of your Starbucks coffee. If you get a robust roast, it's kind of a strong roast. The opposite of that is gracile, just so you know. The ulna and the radius, similar to the tibia and fibula, are not fused. And our fingers have kind of a little broadened area called an apical tuft, which we will not see in most other animals. They have usually claws on the end of that, unless it's a primate. Other mammals designed for front and back stride. They're not climbing or doing this above arm, hand over hand, holding their arms above their head. Remember, we're just talking about forelimbs here. Clavicle is often absent in most non-human animals, or it's fused to something else. The humerus, radius, and ulna are all weight-bearing, therefore they're much more robust. Ulna and radius are often fused because they're weight-bearing. Finally, they have a very tiny, if even extent, thumb. And even on mammals with similar hands, they tend to have claws, no apical tufts, and their thumbs tend to be much smaller than ours. Okay. Juvenile remains are by far the most commonly mistaken for non-human. People look at them and go, that doesn't look right. That's because the ends are not fused and they're teeny tiny. Unfused epiphyses increase the number of bones in juveniles, meaning kids have more bones than adults. Children, babies, can have up to 3 times the amount of bones that adults have. By the way, how many bones do adults have? Let's think about that for a second. I'll answer it at the end of the slide. Cranial bones can separate and often lack kind of that spongy bone in the middle, which is the diploid. And they're often confused with tortoise or turtle shell. Conversely, tortoise and turtle shell can be brought forth as skull. There's a few dead giveaways. The biggest one is there are ribs attached to the inside of that if you have enough of it. But we'll not get too far into that. Incidentally, to answer the previous question, adult human bodies typically have 206 separate bones. 206. Remember that. That's probably a good quiz question. All right, moving on. These are non-adult bone. This is a child, right? You can probably tell by the skull. But if that skull was gone, and that skull is tiny, I'm here to tell you that skull is about the size of, I don't know, a softball. Okay? So, all of the rest of these bones laying around here are human baby bones. They belong to a lot of different children. This isn't just one kid here. But what we have represented here are things like this is the forearm bone called the ulna. This is the other forearm bone called the radius. Now these two bones, they're only probably about maybe 1/8 of an inch in thickness. They're tiny. For those of you who don't know what the hell 1/8 of an inch is because you come from one of the progressive countries that use the metric system, let me say they're about 2 to 3 millimeters thick, maybe up to 5. All right, here we have, this is a child's femur bone. You don't have that really obvious head of the femur, that big ball that comes off the sides of these usually. Here's another femur bone. And another, and another, and another, and another, and another. There's a lot of them. Here's a child's scapula. That's their shoulder blade. But again, it's missing a lot of the ends and little bits that really sell it as a shoulder blade when we see an adult. This is a child's clavicle. That's their collarbone. All right. So they're super tiny. They're easily mistaken for other bones. And they're for other animal bones, I should say. And they are often overlooked. Plus, they're so tiny, they can be lost. This, another little interesting part here. This is a child's mandible. It's a lower jawbone. And in here are teeth starting to form. So an interesting thing you can do oftentimes with baby mandibles, if you suspect it's a baby mandible, not a hyoid bone, which looks very much like this, comes from an adult, you can shake it. And if you hear those rattling teeth on the inside, dead giveaway. Come to talk of it. Okay. Here on the left-hand side is a very young infant mandible. You can see this thickening here. This is where the teeth are forming inside that bone. Here's an older child. This one here is probably about, I don't know, maybe 3 to 4 months old. This is a brand newborn. This is probably 3 to 4 months old now. And you can see these lumps start to appear where the individual teeth are. Here's one. All right, and here's some on the outside you can see. Okay, so now it's starting to form the rest of the mandible that looks more typically mandibular to us, like an adult mandible. But here, man, this looks just like an adult's hyoid bone if some parts are broken off. So it's very confusing. Again, infant bones brought from a burial. These are slightly older. You guys can see this is in metric, so you guys can see these are centimeters here. 1, 2, 3, 4, 5 centimeters. Okay, which gives you a pretty good idea on size. For those of you who don't know the metric system, first of all, if you're going to pursue science, you should learn it, because everybody else except us and one other country that I know of, which is Myanmar, are the only two countries, Myanmar and us, the only two countries that still use the old imperial system. Everybody else uses the metric system. So those of you who are not aware of what a centimeter is, it's about somewhere between 1/2 and 3/4 of an inch, okay? A centimeter. Millimeters are 1/10 of a centimeter, okay? There you go. Skull fragments. These are very typical in look, but the biggest giveaway for a skull fragment is they will often have these squiggly lines. This is known as a cranial suture. It's where the two skull bones are fusing together. Furthermore, on the edge, you can just barely see in this one. You can sort of make it out in this one. It kind of looks like a sandwich, where you have the smooth bone on the outside, smooth bone on the inside, and in between there is what we call trabecular bone or cancellous bone, or some people call it spongy bone because it looks like the edge of a sponge. But I'm here to tell you it's just as hard as the cortical bone or the smooth bone on the outside. It's made out of the same stuff, it's just a different shape. It's got those holes in it. So the first thing, if you have something that you suspect might be skull, look at it on edge. If you can find a broken edge to look at, you'll see these little kind of holes in there. It's actually better to see here. They're roughly, here we go again, about 1 centimeter thick, or, in an adult anyway, or about 3/4 to 1/2 an inch thick, generally, in adult humans. Here is what happens when bones get fragmentary. And still, can we tell that these are non-human bones? The answer, yes. Biggest thing is, if we've got a bison bone, a bison, for those of you who don't know, that's the American buffalo. It's a very large animal. Have huge bones. Here we have one of those round bone shafts. Look at what the diameter of this would have to be. Now here, in a pinch, this is an old school thing. In a pinch, people would throw down a comb because back in the day, we're talking the 50s, 60s, 70s, everybody carried a pocket comb, especially uniformed officers or, people working in this capacity, very conservative group. So they tended to carry pocket combs, and most everybody knew the rough size and shape of a pocket comb. So it was a kind of a last-ditch effort for a scale. You saw in the previous picture where I was explaining how big a centimeter is. That's a typical modern scale, but this is, hey, I found a ton of bone here. I'm going to throw this down, take an image of it, and bring it into the office and see if this is something we should be concerned about, which is very helpful for us. And it's actually something they train police officers to do. They'll use anything that has a typical size that's usually recognizable. Handcuffs, wristwatch, their badge in some cases, and in other cases, they'll throw down sometimes a wallet or keys. I've seen everything, okay? But what this tells us is that the diameter of this shaft would have been probably nearly 3 inches in diameter. That is way too big for any bone that comes out of a human body. All the rest of these are not the right size and or shape for human bone. They're much too large. Therefore, we can know, even with these fragmented, smashed up bits of bone, we can still say, nope, not human. Here we go again. This is burned bone. We'll talk a lot more about it later on. Now, this is much more similar in size to human bone. And if the fragments are too small for us to determine which bone it was, for example, if we have this mid shaft here and both ends are burned, it's calcined really badly. We'll talk a lot more about that later on. This is very confusing as to whether it's human or not. So now this is one we'll have to bring back to the lab to make sure. Now here we've included photographs of where these bones were found. Here's a house. They found the bones in the yard of the house, and oh no, is this person a serial killer? Nope. Turns out they just had a pig roast. And oftentimes people go out, they'll buy a house 30, 40 years down the line after they had a big in-ground, dig out a big pit and make a pig roast. This happens all the time in Hawaii, by the way. They'll have a pig roast, and then they'll just toss all the bones in there, leave them, cover them up, mow the lawn, whatever. And then, you know, 30 years hence, nobody remembers the pig roast of 1973. So they come up and they go, oh my God, we were digging up to put in a new well, or trying to come up with, something, whatever, doing, I don't know, redoing the plumbing. And all of a sudden they come up with all this. Oh my God, is it a crime scene? No. And you can see they secured the scene early on. You see this? This is crime tape going across the front lawn of that house if you can make it out. And then they came out, oh, no, it's pig bone. Not a murderer, just carnivorous. In the most non-human animal bone, the bone in the shaft is much thicker. We call this thick cortical bone, or stenosis of the bone, which means it's much thicker. That is because it's weight bearing. It's usually much more robust, heavier built, thicker bone than what most modern humans have. So here we have a comparison in, obviously this is a computer, but we're looking at the cross section. If we cut it in half and look down the middle of the shaft of the bone. Okay. So how do we find graves? Well, we've already talked a little bit about this. We talked about the butterflies, and we talked about other things. Abnormal depressions are one of the dead giveaways, which are roughly the size and shape of a human body. Here is an old, I gotta tell you, it's an old image of a GPR, ground penetrating radar. Now they're much smaller, the sleds that they drag around. But what this does, this sled is firing into the ground either sonar or radar waves that then bounce off the ground and come back up and are read by the machine. The machine will show us, oh, there's an anomaly here or there. Then we've got to calibrate it and find out how big that anomaly is and see, okay, well, that's about, it's roughly the size of the grave that we're looking for. Oh, that might be an area of interest. So we'd mark that, go out, find the coordinates of it, mark it out, and maybe do a little digging and see if there's a human body in there. Abnormal depressions, same thing. If the depression is about the same size and shape of a grave, you might have something there. Well, it's worth a dig. But, as I mentioned before, easiest, most reliable method is always our doggy friends. Those guys have an amazing nose. They can smell decomposition, and they can smell different rates of decomp. Now, granted, if they get all the way to the point where it's completely skeletonized, the grave has been there for 30 years, it's going to be hard for the dog to detect it, if not impossible. There are other things we look for. Pattern disturbances, or that plant growth I talked about earlier. Pattern disturbances are great. Those are really interesting. This can range from virtually anything to anything. It can include abnormal plant growth, or in the case here, we have all of this river rock that's in this wash through the American Southwest. You can see all of these rock have a very blackened surface, except these rocks here have been flipped over, showing their white undersurface. That is abnormal. Doesn't fit with the area. It's not the pattern of the area. Now, I've seen this to an extreme. I've seen trackers in, well, I haven't seen them with my own eye, but I know of stories of trackers in places like Australia who can look at a spider web and say that's not the right pattern for the spider web, and they can actually find that it's been disturbed. Things like that, which are amazing. But the point is knowing the area. So oftentimes we'll work with locals who know the area, outdoorsmen and women who know the area very well and say, you know what, that doesn't look right. And sometimes that's all we need to start an investigation. Funny thing about those cadaver dogs, our wonderful friends, the cadaver dogs, they can even smell a cadaver through the water. Those cement shoes don't work as well as the mob would have you think. We can take a cadaver dog out on a boat with, obviously we have here the doggy plus a diver. So they're driving the boats around, search and rescue, sheriff, whoever we have that has a boat. Here we have, quite obviously, a lake, but we can do this in rivers. It's harder in the ocean because the ocean currents can actually move those smells around. So by the time they get to the surface, they may be hundreds, if not thousands of feet or meters away from the body that we're looking for. So they work in conjunction with the dog. Now, just to clarify, the dogs don't go in the water. Not for the search anyway. They might want to go swimming later. But for the search, the dogs stay on board. And then the divers, when the dog indicates, the diver will go in and start searching. And oftentimes it's quite murky down there. It's hard to find. Finally, man, there is a lot. I usually don't even use this slide. There's a lot of misinformation out there. Obviously, you guys, this is Photoshop. There aren't giants. And I know there's all sorts of videos and stuff out there. Put on your pseudoscience helmet, and no, there aren't any giants. But this is one of those slides, a tongue-in-cheek slide, that is to tell you size matters. If the size doesn't work, it's not human. By the way, this is faked. This is a hoax. It's Photoshop. Okay, you wonderful people. You're now probably gearing up for the exam, so I would suggest going back through, watching all the videos again, and possibly I always suggest getting into a study group. I'll facilitate it online. We'll talk about it at the end of the week. All right, you guys, have a wonderful rest of your week.